Hi everyone, it's Mr. O'Sullivan. Today is January 4th. Sorry that I'm going to be out today, but the show must go on. Today we're going to be starting a new unit where we look at sequences. We started this in Algebra 1 2 years ago, but now we're going to do some more fun things with them. So today is basically sort of like a recap lesson of what we did in Algebra 1 with arithmetic sequences. So make sure that you're filling in your note sheet as you watch. That way you will understand how to do your independent practice. So today's learning target is I can apply my knowledge of linear functions by extending them to arithmetic sequences. So if you remember way back when in ninth grade, an arithmetic sequence is basically this. A sub n equals a sub 1 plus d times n minus 1. And sequences are just lists of numbers. So like 1, 3, 5, 7, 9, 11, ... Goes on forever and ever and ever. That's just a sequence of numbers. So I can say this is my first term, my second term, my third term, my fourth term, and so forth. So when we're looking at this right here, we're saying that a sub n represents our nth term. So it could be my fifth term, it could be my 10th term, it could be my 20th term. We say that a sub 1 represents our first term of our sequence. N is our term number, so basically if I want to find the fifth term, I'd plug in a 5. And then D is our common difference. So if you're ever stuck on how to find your common difference, all you have to do is just do term 2 minus term 1. And what I want you to think of common difference as is sort of like your slope sometimes. And then like a sub 1 in a way is like sort of very similar to your y-intercept, but it's not your y-intercept, but it's very similar. Also, just know that an arithmetic sequence will always be linear when it's simplified. So it'll go back to that y equals mx plus b. Now, before we get into arithmetic sequences and how to use them, let's just go over some quick sequence problems first. So, exercise. A sequence is defined by the equation a sub n equals 3n minus 2. For part A, what we would like to do is we would like to find the first three terms of the sequence denoted by A1, A2, A3. Do not say A little 1, A little 2, A little 3. So if I want to find the first three terms of my sequence, I would simply just plug these values in for n. So if I want to find A sub 1 for A sub n equals 3n minus 2, all I would do is this. A sub 1 equals 3 times 1 minus 2. And then I can do that mentally, or I can type it into my calculator. And if I type it into my calculator, I get 1. So that is my first term. If I want to find my second term, I just do 3 times 2 minus 2. And I can do that mentally also. Or if I type it in the calculator, I just get a 4. Then, if I want to find my third term, because the question's asking for the third term, I could do a sub 3 equals 3 times 3 minus 2. And if I type that in also, I get a 7. Now, if you notice, my terms go up by 3 each time. To go from a 1 to a 4, I add by 3. And to go from a 4 to a 7, I add by 3. That should make sense because if you think about it, this function right here is linear, which means that it's arithmetic, which means that it's going to go up by a constant rate every single time. Now, for part B, it says which term number has a value of 70. So I sort of have to think, okay, what number am I plugging in to get that 70? And it really isn't that bad because I can just set up an equation. So if we know that a sub n is equal to 3n minus 2, and we want to find out the term number that has a value of 70, I can just put 70 in for a sub n. And now it becomes an equation to solve. So I look at it for a minute, I'm like, okay, how would I solve this? So I can draw a line down my equal sign. I can box that 3n. And I can ask myself, okay, how do I get rid of that subtract 2? So to get rid of that subtract 2, I can add 2 to both sides of my equation. So I add 2, and then I get 72 equals 3n. And then I can ask myself, okay, so now how do I get rid of that 3? Well, I just divide. So I divide by 3, divide by 3. And then I get n is equal to 24. So we're basically saying that the 24th term would have a value of 70. And I can actually verify that by checking. So if I wanted to check that, I could just do a check. And I can do a sub 24 equals 3 times 24 minus 2. And if I type that into my calculator, I do get 70, which is exactly what I wanted up here. Okay, now let's go on to this arithmetic stuff. So we have the sequence 5, 9, 13, 17. The first thing we want to do is we want to figure out if it's arithmetic. So we said arithmetic sequences are linear, meaning they go up by the same value or go down by the same value each time using addition or subtraction. So if I want to figure out if this first sequence is arithmetic, all I have to do is ask myself, how do I go from a 5 to a 9? And that's by addition, by a plus 4. How do I go from a 9 to a 13? Well, 9 plus 4 is also 13. And then 13 plus 4 is 17. So I can see that this is arithmetic. So yes, it's arithmetic. And now I need to ask myself what the common difference is. Well, the common difference is the number that you're going up or down by every single time. So if I look, I'm going up by a 4 each time. So I can say my common difference is 4. Now, for part C, it says if it's arithmetic, write the explicit formula. So we know our explicit formula is this thing right here, that a sub n equals a sub 1 plus d times n minus 1. You do not have to memorize that. It is provided on your reference sheet. And now we just plug in our known information. So we know what our first term is. Our first term is a 5. Our common difference is the number we're going up by each time, and we said that was a positive 4. And then we just have n minus 1. Now, to practice simplifying, whenever you have a number attached to the parentheses, we know to distribute, so let's distribute that 4. And then let's combine our like terms. Well, if we look, our like terms are 5 and a minus 4, and 5 minus 4 is 1. So I can say that a sub n is equal to 4n plus 1. And that is my rule that can help me find every single term of the sequence. Now let's look at our other sequence. In this sequence, I go from a 7 to a 4 to a 1 to a negative 2. So if I go from a 7 to a 4, that's going down, so I'm definitely subtracting. So I'm going to say minus 3. And if I go from 4 to 1, that's also a minus 3. And then 1 to a negative 2 is also a minus 3. So I can see that this is arithmetic as well because I'm going down by 3 each time. Now my common difference, we just said it before, negative 3, because that's what it's going down by. And now for part C, we want to write the explicit formula. So we know our explicit formula, again, is a sub n equals a sub 1 plus d times n minus 1. And now we make our substitutions. So we get a sub n equals my first term, which is a 7. Our common difference is a negative 3. And then we have our n minus 1. And I said it before, whenever you have a number attached to the parentheses, we distribute. So now we have a sub n equals 7. Negative 3 times n is a minus 3n. Negative 3 times negative 1 is a positive 3. And now we combine our like terms. And 7 plus 3 is 10. And that would be my explicit rule. Okay? Now, let's go on to this challenge question, because you are going to be asked to find out how to do one of these on your independent practice. So it says, given that a sub 3 is equal to 14 and a sub 6 is equal to 26, determine the value of a sub 30. So I'm giving you the heads up. This is an arithmetic sequence. Here is how we're going to solve it. Follow these steps. For part A, it just says find the common difference using the terms provided. So to find our common difference, all we're going to do is we're going to treat these as ordered pairs to find our slope. So basically, a sub 3 being 14 is really just 3 comma 14. And then a sub 6 equaling 26 is really just 6 comma 26. So we're going to find our common difference by using our slope formula, which we learned in our last unit. And then we're going to plug those points into our slope formula. So we're going to do 26 minus 14 over 6 minus 3. And if we type that into our calculator with an alpha y equal, we should get 4 as our common difference. That's basically telling me that my slope or my common difference is 4. Now for part B, it says substitute back in to find the value of the first term. So we now need to find out what the first term is. So we know that a sub n is equal to a sub 1 plus d times n minus 1. We know what our d is. We know our d is 4, so I'm going to put a plus 4 here. We don't know what a sub 1 is, but we do know an n and an a sub n, because if you look, they're telling us a sub 3 is 14. So they're telling me that if I plug in 3 for n, I'm going to get 14 for a sub n. So we can actually make that substitution right here. So I can do 14 equals a sub 1 plus 4 times 3 minus 1. So I'm just using that 3 comma 14 in for a point. And then I can simplify. When I do my simplifying, I get 14 equals a sub 1 plus, if I type this into my calculator, I should get 8. Now, how do I get rid of that plus 8? I subtract 8, and I get a sub 1 to be equal to 6. Now that I know my first term, my common difference, I can now find my 30th term. So I rewrite my explicit rule. We know our first term is 6, our common difference is 4, and then we have n minus 1. We distribute. We combine our like terms, so 6 minus 4 gives me a positive 2. And now I plug in the 30, because I want to find the 30th term. And then when I type that into my calculator, I get 122. So the 30th term of the sequence is 122. So now what I would like you guys to complete is this independent practice. If you have any questions, please send me an email. Have a great day, ladies.